Hello, my dear friends. Today we'll be discussing the part B of the 2022 PO Maths paper, and we'll directly move on to the question that comes on the uh, series. And let's start with this part B. We've been given a UR expression. That the UR expression is uh, UR equals to 4 2R plus 7, and divided by 2r plus 1, 2r plus 3, and 2r plus 5. So once you've been given the expression, they also say also let fr equals to a particular expression where a and b are real constants. Determine the values of a and b such that ur equals fr minus fr plus 1. So better write down the way the ur should be, that is fr minus fr plus 1. So once you are given with that, you have already been given what the value of fr is. Suppose it's a 2r plus 1 and b 2r plus 3. So this is the fr expression you've been given. And also we can write down the fr plus 1 expression as well, because we have two parts, and then it's easy for us to write down the expressions clearly once we know exactly what the fr and the fr plus 1 expressions are. So once you substitute a 2r plus 1 here, once you substitute a 2r plus 1, what you'll be getting is a 2r plus 2 plus 1, that is 2r plus 3. And for the next part also the same, you get a 2r plus 2 plus 3, that is 2r plus 5. So we don't need this. And now that we've found out our data, now we'll move on. Now we'll directly move on to the ur equals fr minus fr plus 1 expression, and substitute these terms for each of these fr and fr plus 1. So again, better write down this ur equals fr minus fr plus 1, and that ur equals to fr is a divided by 2r plus 1 plus b 2r plus 3, and a minus, open a bracket, because there is a, whenever you get a minus, it's better, or it's a must to open a bracket, otherwise you'll mess up with the simplifications. So next is a, denominator is 2r plus 3 plus b, denominator again 2r plus 5. It's better since we've already simplified them before, we just need to substitute them in here. So now we'll further simplify this, that is remove the brackets, 2r plus 1 plus b 2r plus 3 minus a 2r plus 3 minus b and a 2r plus 5. Once you have done with that particular part, we can substitute this ur and get a single expression. Because I had less space, I ignored the ur expression. Now I'd better write it down. The ur expression is 4 2r plus 7 divided by 2r plus 1, 2r plus 3 and 2r plus 5 is our UR. And now take the A values on the one category, A minus 1, 2r plus 3, then the B values, B expression separately, plus a B, 2r plus 3 minus B, 2r plus 5, 2r plus 5. Now if I simplify this separately, I will simplify this. It's better if I simplify towards the left hand side, because there will be space problem when we write the B expression simplification. So once I simplify this, you get 2r as a product, you can write this, and then A into 2r plus 3 minus A into 2r plus 1, plus again with the B expression, write the denominators as a product, and 2r plus 5, and then a B, then get that opposite side 2r plus 5, and a minus B with 2r plus 3. And once you simplify this, actually this step is not must, because I wanted to get the UR in terms of its expression, so that's why I got this, and it's easy for me to move downwards without going up and checking the expression again and again. So now we'll move on with this. Once you simplify this, you get 2r plus 1, 2r plus 3, and up top part you better simplify. 2ar will be cancelled with minus here, then 3a minus a, 3a minus a, in the sense it's a 2a, right? It will become a 2a. Plus simplify the b here, 2r plus 5, 2br will cancel off. That means you are remain with 5b minus 3b, that will become a 2b. So now again better write down along with the UR expression itself, like as of in the top. We've simplified this whole thing. Now we'll better write this down as for 2r. This is just a waste of time, because this is just a discussion video. I'll be writing everything clearly so that you can comprehend the way I am simplifying, and later you can discard the unnecessary steps and write down the main steps that you'd be allocated marks with. So again, 2r plus 1, 2r plus 3, 2r plus 5 equals to 2a, 2r plus 1 and 2r plus 3, plus 2b, 2r plus 3, 2r plus 5. So once you simplify, you should multiply this whole expression by the denominator part of the UR term. 2r plus 1, 2r plus 3 and 2r plus 5. Once you multiply with this expression, there are certain things that will be cancelled off. Now it's already a simplification part, okay? So now you can see that this 2 to 4 will cancel off, and what you are remaining is with just 2 and 8 2r plus 7. And since this will be cancelled off once you multiply this thing with this whole term, and then for the next part we'll be having a 2r plus 1 will be cancelled off, 2r plus 3 will also be cancelled off. What remains is 2r plus 5. Next is b, 2r plus 3 will be cancelled off, 2r plus 5 will also be cancelled off. What is remaining is this 2r plus 1. Afterwards, you just have to identify these unknown terms a and b. How are we supposed to do it? By equaling of coefficients. By equaling of coefficients. Okay, so just consider r to the power 1, and thereby you get 4 equals to 2a plus 2b, positions where all the r is available. So r to the power 0, that means just the coefficients without any r terms. That here it is 14, it will be 14 here, equals to 5a, no r terms, and again a b. So this will be expression number 1, this will be expression number 2. Once you simplify this, we'd better remove the b. So I'll multiply this by 2, so that we get in 28 plus 10a plus 2b, and that will be equation number 3. And I'll have to deal with only equation number 1 and equation number 3, because we are going to remove that 2b from the expressions and find the value of a quite easily. So I'll say 3 minus 1. So 28 minus 4 is 24, equals to 10a minus 2a is 8a, and then 2b minus 2b is 0, and the value of a will be getting is 3. And then now that we have found out a equals to 3, we can substitute in on easy, quite a simple equation out of these 3. That would be substituting in 1 would be the best option, that is 4 equals to a plus 2b. And then once you substitute 3 to this particular a, it will be 2b equals 4 minus 6, right? So 2b equals minus 2, that in the sense b will be equal to minus 1, right? Now that we have found out both the unknown terms a and b, we'll directly substitute them for the fr value that is already expressed in here with a and b terms. So now that we found out a and b, substitute the values in the places that it is we are expected to write. So now that the fr, hence this fr equals a value is 3, denominator is 2r plus 1, plus b is a minus 1, the denominator is 2r plus 3. So this is our fr expression. So now that we'll have to move on to the ur equals fr minus fr plus expression again, according to the theory concepts you have learnt in your classes before. That is the next procedure that we'll have to follow. Then get the final summation of the ur expression in terms of n, and then find the limit, and then get a value whether it's finite or infinite. And that's pretty much all with this question. So now we'll write this down in answer. So let's read the question again to get to see what we have done. And also let FR, where A and B are constants, determine the value of A and B. We did that. So, and we also be substituting that FR as well. That's not actually asked, but it's better if you could do it, because this FR is like not incomplete, no, so like that. So you are now write the UR expression. Again, UR equals FR minus FR plus 1. So this is the major scenario. And afterwards, we'll have to substitute for each occasion when R equals to 1. And then once it is 1, what the expression would look like. So it will be u1, right? For every r term should be substituted with 1. Next step, r equals 2, each and every r term should be substituted with 2. Like that, move on for several steps and then finalize. So here it will be f1 minus 1 plus, I've written 2 pluses, right? Just ignore 1 plus. That is 1 plus 1 would be 2. So when r equals to 2, better write 3. u2 equals f2 minus f2 plus 1 would be a 3. Then when r equals to 3, you get the u3 expression as f3 minus f4. And then keep some dots that it will be continuing up to n, since writing that much of steps is not important or needed even. Now we'll come from the n towards up. So I'll write when r equals to n minus 1, u n minus 1 equals f n minus 1. Once you add a 1 here, it will become a n, that will be a fn. So once r equals to 1 n, so un, and this top part is n minus 2, right? Like that it will move on. So fn with the r plus 1 in the sense n plus 1, since n is what is substituted. And once you summate this whole thing, the final answer you'll be getting is in terms of a summation. Sigma notation, you might have heard it. That is up to n from n r equals to 1. This is the range that we write from this particular place to this particular place. The whole summation of ur, of this ur, is equal to, now we can see, I'll use another color. You can see this f2 cancels, so f3 cancels. Similarly, this should also have the potential of becoming cancelled off, and here also this cancels off, here also this may cancel. So what you are remaining is with this one and this term with the minus. Okay, you cannot ignore the sign in front of it. So I'll move the color again to black. That would be, what is remaining is f1 minus fn plus 1. So now simplify this, the f1. So we know the fr, right? We know the fr. So for the fr, once we substitute 1, see the fr here, that's the importance of writing down the fr. Okay, this fr is very important. Once you substitute 1 for this fr, like I'll separately write down, if this r becomes a 1, and for each of these r places if you substitute 1, what would be the answer? That is, I'll write 3 divided by, if it is 1, 2 into 1 is 2 plus 1 is 3 minus, here 1, 2 into 1 is 2 plus 3 is 5, minus 1 divided by 5, that will be 1 minus 1 over 5, that is 5. 5 divided by 4, right? 4 over 5. So f1 is 4 over 5. So that is what you expected to write. You can simplify it in here as well, no problem at all, because my fr was at the top part of my one knot. I had to go there, and now it's a bit troublesome to come upwards and downwards, so I just simplified back there itself. So it's better if you are able to simplify here itself. Then the exam marker, the examiners can easily see that you have understood the concepts and you substituted in the actual procedure by knowing the FR and then substituting one separately and then simplifying and finally getting 4 over 5. So I'll just write this F1 is actually 4 over 5. Now Fn plus 1. So we'll have to move on to the fr plus 1 part. Fr plus 1 part. So if we'll have to move very up very much of yeah, this part. So this, now we dealt with this one and now we have to deal with this. So if r plus 1, so here you can see this a value, it takes a value is indeed a 3, and once you substitute this n plus 1 in terms of this fr plus 1 only, you are able to write it down. So we'll directly substitute here. We'll directly substitute like a divided by 2r plus 3 it actually was I'll write with that exact term itself, a divided by 2r plus 3 and a plus b divided by 2r plus 5. It is something like this, no? It's something like this. And once you simplify, it's a minus here because the b was now you see, now I'll write the plus here and now simplify. Minus a value was 3, no? 2r plus 3 and plus b is minus 1, so that is 2r plus 5. And fine, you don't need to carry on like this actually, since this is a discussion video. I'll explain how each step is verified clearly, so that each step is verified easily. And again simplify. Now that it is, we'll remove the brackets, 2r plus 3, and here it will become, overall it's a minus, and minus into minus is a plus, and it will be 2r plus 5. So that's the major scenario that we'll be observing here. So we almost come to the end of finding the getting the final answer. Now what we are left is, we cannot further simplify this. We don't need actually to simplify this further. So now we need to find the limit. So when n r equals to 0 and whereas when n reaches the infinity, n goes to infinity, or the limit actually, or we can say the limit of n moving to infinity, you can see that ur equals to limit when n goes to infinity. Write down the same expression again. Okay, write down the same expression again, and only with the hope of finding the limit up to infinity. So you know that when there are unknown terms in fractional form, we can send the limit to 0, and finally what we are remaining is with the finite value of 4 divided by 5. So there is no need of again finding the limit and for f4 or 5, and then you can finalize your answer. um, since since sigma n r equals to 1, ur is a finite value, the answer equals to the summation equals to 4 over 5. So hence it is a finite series. So those are the conditions. Now the conditions, what the final output of your final answer, and what you got to know from that answer, that this is a finite or infinite series. So we have completed up to here. So the question says that see now I just did the question without look. I just did the answer and followed the simplification steps without even looking at the question. So if you are if you go on reading the question and answer, and also you can verify that the way of approaching your answer is quite the way you have expected. So the answer itself given in the question paper should be available in your final output. That says hence or otherwise show that sigma n r equals to 1, ur equals to 4 5 minus 3, 2n plus 3 plus 1, 2n plus 5. So that's in terms of n. I think I made a little mistake. You see I got that this thing in terms of r, no, just to because the fr plus 1 expression is this particular, I write with green, this particular expression was the fr plus 1 expression, right? I directly substitute the expression. Then I did was to substitute in a and b expressions were not expressions, the terms were substituted with 3 and minus 1. And finally what our expectation was to take this up to give this the n term, no, this comes under with this comes with n terms. So instead I just to show you guys that this is the way you approach the answer, I have taken r. So it's okay even you take the r and come downwards, and finally you need to show that this final output comes with the n, because there should not be a single answer in terms of r but with n. So here also r, same thing I have written, and final answer I also written with the 1 up to n. It shouldn't be r, it should be n, because final target is the n. So I have to make a correction here, that is this r should be a n, this r should be a n. So here also the r should be a n. Everything runs with n now, not the r, because we have the expression, we got the final summation f1 minus fn plus 1. So it's not r plus 1. If it was r plus 1, then totally fine. So you have to revert this all the r into n, and that's pretty much all. So in terms of n, it's like this. I hope you understood what I mentioned last. It was a big mistake if you did this in exam, though your concepts are right. Since just because you have substituted a little r instead of that n, you have the higher probability of losing your marks. So what they ask us next is hence find the value of the real constant k such that the sigma infinity summation infinity ur plus k ur plus 1 equals to 1. This is another section actually. It's not related with the part, but we'll move on. So find the value of real constant k. First we'll write down the expression. We'd better write down the expression. That is sigma infinity r equals to 1 ur k ur plus 1 equals to 1, right? So you can further expand this. How? Ur actually here k into one k into ur plus k into u1, k into u1 equals to 1, right? And then I can take k plus 1 out, I think k plus 1 out. So I'll take 1 plus k out, and then the sigma infinity r equals to 1. So this one, right? ur, then a ur here. Okay, with the sigma we took the 1 and the k out, and then bind this with this particular sigma notation. Then finally you must add this part plus k u1 equals to 1. So u1, now we know this value, right? Ur sigma up 1 up to infinity, we know the value, that is 4/5. So 1 plus k into 4/5 minus k, because this u1 as we this u1 here, if we substitute u1, the answer for this expression is going to be 12 minus 35. You better simplify that and see for yourself. I'm not going to simplify that here. So this is what you get here. There will be minus, okay? It is minus 12/35 equals to 1. So now better simplify this. That is 1 into 4/5 is 4/5 plus k 4k/5 minus 12k/35 equals to 1. And now this is just the simplification part. As I mentioned, just better try out that u1, okay? Take the u1 and substitute the 1 for the ur, and then you'll be getting that means, you see in the paper, look at the paper here, once you substitute 1 for each and r term, the answer you'll be getting is minus 12/35. That of course we are not expected to write it in the paper, just it's a do it in your rough paper and get it here. So finally once you can write this with the k terms separately, you can write the k terms separately, minus 12k divided by 35 and 1 minus 4 divided by 5. So once you simplify here, 35 is a common, then 7 is what is there, 35 5 is 7, 7 of 4 is 20, 8k minus 35 1, that is 12k divided by 5 over 1 over 5. Okay, once you simplify it, and then simplify, move on simplifying. What you finally asked is to find the real value of k constant. Okay, so we're just approaching the answer. So 28 minus 12, that is 16, right? That is 16 k divided by 35 equals 1 over 5. Now subject k, that is 35 divided by 5 into 16. 5 divided by 35 is 7. So the k value you'll be getting is 7 over 16. So the final answer for k is, the real value is 7 over 16. So guys, that's all that we had to do in this question. So this is a hence part, we did that as well. So we reduced as a infinite series, and we knew that it's convergent. Better if you write at the last part that this is a finite series and is also convergent. Okay, because it's convergent only, it becomes series. And then we now, from bottom to top, I am telling you guys. And we also found out the expression that when nr equals 1 ur expression that they've asked us to find, and then we found if r values with the ab constants, having found out the ab constants separately. And that's pretty much all when dealing with the question and the series. And this is the similar pattern that you'll be seeing in all the past paper questions before. So that's all guys for today. Thank you for listening, and please subscribe to my channel, and I'll be uploading more videos and discussions of the past paper questions as much as possible, especially the essay parts, because they are the parts that you are dealing with the majority of the marks for it. So it's the turning point for a better result. So thank you guys, have a nice day.